Here's a sneaky screen classic, Ransom Note. It looks trivial, just letters, but interviewers use it to test whether you instantly reach for frequency counting instead of slow searches. Master this Pattern Mastery 100 problem and you'll crush dozens of can I build X from Y problems in linear time. Let's knock it out with basic. Breakdown. We're given two strings, ransom note and magazine. We must return true if ransom note can be constructed by cut and pasting letters from magazine. Each magazine character can be used at most once, only lowercase letters. Assess. The right tool is frequency counts. Count letters in magazine, then scan ransom note and check we never request more than we have. With only lowercase letters, a 26-slot array is faster than a dict. Complexity, O(n plus m). Time, O1 space. Structure. Make an array CNT26 equals 0. For each char in magazine, CNT IDSC plus equals 1. For each char in ransom note decrement, if any goes negative, return false. If we finish, return true. Let's try to implement it using solution 1. First, we import Python's collections module. This gives us access to Counter, a super handy tool that counts how many times each character appears. Think of it like a built-in character inventory system. Now we define our solution class. This is our main function. It receives two strings. Ransom note, the letters we need. Magazine, the letters we have available. Our job is to check if the magazine provides enough characters. Here, we count how many of each character the ransom note requires. If the ransom note is AA, this counter becomes A2. It's like saying, we need 2 of these. And now we count the letters in the magazine. This tells us what resources we have available, basically the inventory we can pull from. Next, we loop through every character the ransom note needs and how many of each it requires. So for OB, we'd get a 2, B1. This is the key check. We compare how many of this character the ransom note needs with how many the magazine actually has. If the magazine doesn't have enough, we immediately know the answer is false. And if at any point we find a character shortage, we return false right away, because we can't build the ransom note. If the loop finishes with no shortages, that means every required character exists in enough quantity. So we return true. Yes, we can construct the ransom note. Solution 1. Test case 1. Let's test our function using this input. Ransom note equals A and magazine equals B. These two strings represent the letter we want to construct, and the pool of letters we are allowed to use. Here's why the solution works. The algorithm counts how many times each character appears in the ransom note, and then checks if the magazine contains at least the same number of each character. In this case, the ransom note needs 1A, but the magazine only has B. And that's exactly what our program outputs, false. That means we cannot build the ransom note with the letters provided. So, our implementation is correct. The algorithm successfully compares character frequencies between the ransom note and the magazine. Simple, efficient, and completely reliable. Let's try to implement it using solution 2. We start by defining a solution class. This is just the wrapper LeetCode expects. All our logic will live inside a method of this class. Here's our main function. Can construct. It takes two strings. Ransom note, the text we want to build. Magazine, the pool of letters we're allowed to use. We'll return true if the note can be formed, and false otherwise. First, we create an empty dictionary called count. Think of this as a frequency table or a little letter warehouse. It will store how many times each character appears in the magazine. Now we loop over every character CH in the magazine string. We're walking through the warehouse and tallying how many of each letter we have available. Inside the loop, we update our dictionary. Count.getCH, 0, says, give me the current count for this character, or 0 if it's not there yet. Then we add 1 to that value and store it back. So if the magazine is OB, after this loop, count becomes A2, B1. Next, we start a second loop, this time over each character CH in the ransom note. Now we're on the spending side. For every character the note needs, we'll try to take one from the dictionary. This loop runs once per character in ransom note, so this part is ON where N is the length of ransom note. This if checks whether we can spend a character. 2 failure cases. The character doesn't exist in count at all, not in count, meaning the magazine never had it. Or it exists, but its count has dropped to 0, count equals 0, meaning we already used them all. If either is true, we can't build the ransom note, so we'll return false. If we hit this line, it means we tried to use a character that the magazine can't supply. So we immediately stop and say false, the ransom note cannot be constructed. If we do have that character available, we spend 1 by subtracting 1 from its count. It's like taking 1 copy of that letter off the shelf in our warehouse. We keep doing this for each character in ransom note. If we finish the entire loop over ransom note without running out of any character, that means the magazine has supplied every letter we needed. So we return true. Yes, the ransom note can be constructed successfully. Solution 2. Test case 2. Next, we test with ransom note equals AA and magazine equals AB. The ransom note needs 2 A characters, but the magazine only provides 1 A and 1 B. Our algorithm checks the magazine count and quickly notices that after using the first A, the count drops to 0, meaning the second needed A is not available. And once again, our program outputs false. Perfect. This matches the expected behavior. So, our implementation is correct. The algorithm successfully checks whether every character in the ransom note can be matched using the magazine's letter supply. Simple, efficient, and reliable. So, let's wrap up what we learned from this classic ransom note problem. It's a simple yet clever test of understanding how to use counts efficiently. Breakdown recap. We started by looking at what the task really means. We need to see if we can build one string entirely from another, using each letter only once. It's all about matching letter availability between the two. Assess recap. We compared possible approaches and realized that counting each letter's frequency was the cleanest way. Since we're dealing with lowercase letters, a fixed size array made it both fast and memory friendly. Structure recap. Our plan was simple. Count every letter in the magazine, then spend those counts as we check through the ransom note. If we ever need more letters than available, we stop right there. Otherwise, we're good. Implement recap. We put this logic into code, ran it on LeetCode, and the implementation worked without any errors. Check recap. After running multiple test cases, we confirmed that the logic holds up. Every check passed successfully. The key takeaway here is how powerful simple frequency counting can be. When faced with problems about matching or availability, thinking in terms of counts often leads straight to the most efficient solution.